Scientists have explained what would happen if an asteroid was on a collision course with Earth to emphasize the need for planetary defense. The hypothetical asteroid scenario illustrates how an asteroid threat might evolve over several years and the potential devastation such a strike could cause. The team led by the manager of NASA's Near-Earth Object, NEO, Program Office Paul Chodas presented the exercise at the 8th Planetary Defense Conference, Opens in New Tab, in Vienna, Austria on Monday, April 4th. The hypothetical situation laid out by Chodas begins on January 10, 2023, with the discovery of a new asteroid that receives the name 2023 PDC. The object is initially designated a potentially hazardous asteroid, PHA, which NASA defines as any asteroid that intersects Earth's orbit at a distance from the planet of around 4.6 million miles, 7.4 million kilometers, or less, and that has a magnitude of 22.0 when discovered, which is only a little brighter than the faintest stars visible to the Hubble Space Telescope. The impact probability of 2023 PDC is initially just 1 in 10,000, but Chodas explained that this steadily increases as asteroid tracking facilities on Earth continue following the rock, better constraining its orbit around the Sun. The scenario becomes serious on April 3, 2023, at a point designated Epoch 1 inch by Chodas. Today is Epoch 1. The impact probability has now reached 1%, Chodas said. The potential impact is 13 years from now, so it's not imminent, but we already can predict the date at which the impact is possible. The potential impact date is calculated as October 22, 2036, and despite this decade-plus preparation time, the NEO program manager explains that important decisions have to be made now. But there are still several uncertain aspects, some of which are characteristics of the 2023 PDC asteroid itself, that will be key to how humanity deals with the threat. One of the first things astronomers will do with their 13-year lead time is to calculate the size of the asteroid better. NASA says, Opens in New Tab, that this is done by measuring the amount of light reflected by the asteroid back into space, a quality called the albedo. The more light reflected, then, in principle, the larger the asteroid is. The difficulty with this measurement, Opens in New Tab, comes from the fact that the albedo is also determined by the reflectivity of the asteroid's surface. That means a small light-colored asteroid could have a greater albedo than a large darker one. As a result, there can be a large uncertainty in the size of asteroids. The size of 2023 PDC is calculated as being between 720 and 2,200 feet, 220 to 660 meters, but it could be as wide as 1.3 miles, 2 kilometers, if the surface of the asteroid is dark. The size of the asteroid is important because not only will it determine how much damage it does, but it will also determine what measures need to be taken to divert it, or whether this would be possible at all. When you have a huge object, even as large as 2 kilometers, 1.2 miles, and there's a very, very small chance of that, then nuclear is really a primary method on the table, Chodas said. That means that for a large asteroid heading to Earth, a kinetic impactor like that demonstrated by NASA's Double Asteroid Redirection Test, DART, recently wouldn't be a diversion option. Chodas explains that 2023 PDC is too close to the Sun to use infrared astronomy to help determine its size, as this light would be washed out by bright light from the Sun. As a result, space-based telescopes that rely mainly on infrared observations like the James Webb Space Telescope, JWST, and the Hubble Space Telescope won't be much help observing this rock. Likewise, the asteroid will be too far away during the early stages of its approach to be measured with radar. According to Chodas, that means we will be initially limited to optical observations to determine the asteroid's size. This limits the amount of data that astronomers can collect regarding 2023 PDC, data that could better constrain the asteroid's size and orbit. One option decision-makers will have during the 13-year lead time would be to dispatch a reconnaissance spacecraft to 2023 PDC. Not only would this help us better ascertain the size and mass of the asteroid, but such a mission would help better constrain another crucial aspect of the asteroid that is vital to mitigating its impact on Earth, its orbit. At the time of its discovery in this hypothetical scenario, 2023 PDC is around 124 million miles, 200 million kilometers, from Earth, too far to properly assess its orbit. It's distant and faint, but it has a very similar orbital period to Earth. In fact, is slightly shorter, which means the asteroid will slowly catch up to Earth, and in 13 years, there's a possibility that both will meet in a little red box, representing the intersection of the orbit of Earth and 2023 PDC. Chodas said, "There's great uncertainty in where the asteroid will be 13 years from now. As we continue to track the asteroid, that uncertainty will shrink until it has actually become smaller than Earth. The reduction of the red hitbox in the team's calculation to less than the size of the Earth means that 2023 PDC is going to hit the planet. Astronomers can then begin to predict exactly where on Earth the asteroid will make contact with the planet. So what's the damage? NASA Advanced Supercomputing expert Lorian Wheeler explained that evaluating the potential damage of 2023 PDC involves building an asteroid impact risk assessment model and considering a lot of different factors, such as asteroid size and other properties, from limited observational data. There are three main types of impact hazards that we model. These include local ground damage due to an explosive blast or fireball, Wheeler said. There's also tsunami potential for large ocean impacts, and for the very largest cases, there's a potential for global climate effects. We model all of these cases and then combine the results to look at the probabilities of different damage sizes and damage severities, how many people that damage could affect, and what regions could potentially be at risk. For the potential sizes of 2023 PDC, the lower size estimation of around 1,000 feet, 300 meters, in diameter represents devastation on the scale of a continent with as much as 2,000 megatons of energy being released. That is equivalent to 133,000 times the estimated energy released by the bomb that demolished Hiroshima at the end of the Second World War. As the size of 2023 PDC increases, the potential disaster its impact triggers grows significantly. At 2,000 feet, 600 meters, in diameter, the impact would border on a global catastrophe scale. The strike of 2023 PDC of this size would release as much as 20,000 megatons of energy, meaning a doubling in size has caused an increase in devastation power of around 10 times. At 3,330 feet, 1 kilometer, wide, the 2023 PDC impact scenario becomes exceptionally grim. At this size, the team calculates that 2023 PDC is much more likely to trigger a global catastrophe. Such an impact would release around 100,000 megatons of energy, equivalent to 6.6 million Hiroshima nuclear detonations. Wheeler explains that there are other factors other than size, such as the asteroid's angle of entry to the atmosphere, that contribute to uncertainty in the range of potential impact energies, and thus the resulting damage severity. The most likely hazard is going to be a large ground impact or low airburst causing a highly destructive blast wave and fireball, Wheeler added. Given the size of the objects that we have on hand here, the damage severities are expected to reach unsurvivable levels, with larger areas of damage extending to areas around it, experiencing fires, structural damage, and extending out to areas of shattered windows. Wheeler continued that for smaller impacts, outer damage areas are a band that could extend to diameters of between 62 miles to 124 miles, 100 to 200 kilometers, outside the main impact zone. This extended damage zone could stretch out to diameters as great as 372 miles, 600 kilometers, for scenarios in which the hypothetical asteroid approaches sizes of 2,000 feet, 600 meters. There is a potentially high number of people that could be affected all along the swath, mostly in the range of hundreds of thousands to millions of people, Wheeler said. Impacts over land cause the most population damage, with averages between 10,000 and 10 million people depending on the location. And if the impact is on the larger size, those ranges could go up to tens of millions to the hundreds of millions range. She continued by explaining that should 2023 PDC hit any ocean, it would trigger a tsunami, but the most harm to populations would come from the asteroid touching down in the Atlantic Ocean, with such a strike carrying the greatest risk of triggering a tsunami that could reach populated areas. The eventual climate change effects of a larger 2023 PDC asteroid strike could eventually affect anywhere from millions to billions of people across the globe. So the bottom line here is that there's a very huge range of potential damage, Wheeler concluded. If it impacts Earth, it could be extremely damaging because the potential consequences are so extreme. How worried should we be? It's important to stress that 2023 PDC is a purely hypothetical object and it isn't on course to impact Earth. In fact, currently, there are no large asteroids predicted to hit Earth for the next 100 years. The object with the highest probability of colliding with Earth was the 1,100 feet, 340 meters, wide asteroid 99,942 Apophis, which was predicted to get dangerously close to Earth in 2068. NASA ruled out this impact in 2021, however, and 99,942 Apophis will instead harmlessly pass the planet. Of course, that doesn't mean there couldn't be an object out there waiting to be discovered that is on an orbit that intersects Earth's path around the Sun. Even so, the scenario that Shondas and Wheeler described for 2023 PDC is quite extreme. In fact, the European Space Agency's ESA Director of Operations Rolf Denzing congratulated the scientists for developing a challenging and dramatically unfolding scenario for decision-makers to consider. To consider how likely such a scenario is, the team laid out the probability of Earth being bombarded by objects from space of various sizes, suggesting impacts involving larger bodies should be rarer. The average time between impacts by objects with diameters of around 1,000 feet, 300 meters, is around 70,000 years, while asteroids with diameters of around 2,000 feet, 600 meters, are predicted to hit the planet roughly once every 200,000 years. Massively devastating global catastrophe causing asteroids with diameters of around 3,300 feet, 1 kilometer, are estimated to hit the planet around once every 700,000 years. Even larger 3-mile, 5 kilometers wide asteroids are predicted to strike Earth around just once every 30 million years. What do you think about this topic? Let us know in the comments.